guys, so this lecture, but these lecture notes will be a little bit different because I currently have a quiz tomorrow. Yeah, tomorrow morning, 11:30, I guess. So it's from another course. I'm just doing some just recording for future purposes. Okay, so I don't know if you can hear me, but just okay. Okay. Yeah, okay. So we're going to start with CPR101, which is computer principles for programmers, I guess. Oh no, I just don't care that much. Okay, so we're going to start with computer storage. So there are two types of computer storage. Oh. Sorry, I'm just checking something. So the computer storage has two types: volatile memory and non-volatile memory. So volatile memory is also known as primary storage, and it needs constant power to retain data. Okay, here we can find RAM. RAM is random access memory, which makes the device happy. It makes it less stressful. Okay, I don't know if you can get it. There are some characteristics. The main one is it has fast transfer speeds and it has support for CPU, GPU, and FPU calculations. Okay. On the other hand, we have non-volatile memory, also known as secondary storage, and it doesn't need power to retain data. It stores data persistently, okay? And yeah, it stores data persistently. It doesn't go away. Some main examples are hard drives, portable drives, USB sticks, disks, solid state drives, etc., and so on. There are some characteristics, and unlike primary storage, for example RAM, it has slow transfer speeds. Okay. And it transfers information to the random access memory. Okay, the next thing that I'm going to talk about is some main terminologies. It's going to be kind of quick. Okay, so we have RAM, which is random access memory. It makes the device happy. Then we have CPU. CPU is also known as central processing unit. It basically runs the computer, and it's like the main workhorse, is central workhorse. Then we have FPU. FPU comes from floating point unit. It's a co-processing unit that works along the CPU, and yeah, it works with the CPU. For example, the CPU doesn't know how to calculate this thing, so it sends the information to the floating point unit, and the floating point unit makes floating point arithmetic to calculate and solve it, then it sends the results back to the CPU. Yeah, so that's the thing. And finally, we have the GPU, which is graphic processing unit, it has to do with video rendering, video and image processing, and stuff like that. It runs the graphics basically. Okay, and then now I'm going to talk about persistent storage devices. There are two types of storage devices: online and offline storage devices. Online, it has nothing to do with the internet. It means online, I mean it's available to the machine, it's available to the server, and it has high performance. On this side we have several renowned examples. For example, like solid SSDs, HDDs, and cloud access storage. Okay, so first we have solid state drives, SSDs. They are expensive, but they have low performance consumption. I mean, it doesn't get stressful easy. It doesn't get easily stressful. It consumes a lot less than HDDs or the cloud access storage. Okay, it has no mechanical parts, so they are more reliable than HDDs. Then we have HDDs, which are hard disk drives. Okay, and these drives are cheap, but it has a high performance consumption. It has mechanical parts, so it's prone to errors as time passes by. Okay, and finally we have cloud storage, and they are cheap. You don't need to carry like huge data centers in order to store data, but they are cheap, but it has low transfer speeds. So it has like a high performance consumption. Okay, and on the other hand we have offline storage devices. They are primarily for short-term storage, primarily for backups and archiving files that you might not use frequently. And it's low. It is like a slow performance. It has a slow performance. Here we have LTOs, which are linear tape open. Here we have optical disc, like Blu-ray disc. And finally, nearline. No, not finally. We have nearline, which contains MAID. MAID is MAID, which comes from a massive array of idle drives. Facebook Sanders uses huge MAIDs. Okay, and finally, kind of creepy. And finally, we have cloud cold storage. One good thing about cloud cold storage is that they are extremely cheap, but they are really slow. And some examples are AWS Glacier or Backblaze. There are other persistent storage devices that are old, for example, diskettes, disk packs, and tape drives. Okay. Then we move on to some more definitions. For example, a drive. What's a drive? A drive is a storage device that is recognizable by the operating system. Okay, and in order to be recognizable, you need to mount the device to the machine. And what's mounting? Mounting is a process of making the file system available to the operating system. For example, I put like a USB stick, and that's like mounting, enabling the machine to get access to the files inside the USB stick. Okay. Then we have files. What's a file? A file is a uniquely named space that is inside a drive. Okay. And yeah, it contains data. And what's data? Data is like, it's simply a collection of a sequence of symbols and characters organized in a file format. Okay. Then we have data formats. How do we know that it's a good data format? Correctly formatted data, okay, becomes more useful, and it has more meaning. And it also goes, it also applies the same principles to a source code. Okay, but there are some characteristics of a good source code. Nicely spaced, it has indentations, it has comments, highly descriptive, so that makes a source code good or great. Okay. Then we have folders or directories. What's a folder? A folder is a space where you can store files or other folders. Okay. And folders within folders are subfolders, and directories within directories are subdirectories. Okay, it's great to have folders because you can organize files. Okay, then we have path name and file name structure. I'm going to put an example here on Notepad. So we have, for example, C. That's in Windows. Users, then student, file name. That's an example. And here's for Linux. In Linux is users, student, file name. Remember that this character is different in this character. Okay, you need to make sure that. So this is a drive letter. This is a drive letter. Then we have the folder. That's the folder. Then we have the subfolder. Then we have the file name. And after this period, it comes the extension, the file extension. And in Linux we have the root, okay, which is the parent directory. Then we have this directory, we have a subdirectory, and the file name, and finally the file extension. And we're talking about now we're going to talk about the file extension. So what's a file extension? A file extension is a type. It's a type of a file. It's a type of a file. Okay, and we can describe it like a group of characters that goes after the file name, preceded by a period. Okay, that's a file extension. And Windows connects the file extension with a proper program that can manage or process the data that is inside a file. Okay, and it's not automatically enabled. You need to manually enable. You need to go to file, not file. Yeah, you need to click here, then you go to view, and then enable file name extensions. Yeah, okay. Then there are some extensions. For example, docx means a Word document. We have txt, which is plain text. We have C, which is a C source code. PHP, which is a PHP source code. GPG, which is JPEG image. Then we have XLS or XLSX, which is a Excel file. We have HTML, which is an HTML file. We have CSS, which is a cascading style sheet. Then we have RTF, which is rich text format. Then we have zip, which is a zip compressed file. We have exe, which is executable file. And finally we have PDF, which is portable document format. Okay, we have some naming conventions. Why do we need to properly name a file? Because it's easy to search for it, it's easy to work with it, and it's easy to understand it. Okay, and we need to make sure that it needs to be clear. It needs to have a proper identifier of content. It needs to have a proper identifier of the creator of or author, and yeah, it needs to have like the correct file extension, and that's pretty much it. Then finally, something unnecessary but maybe useful. There's some basic stuff, for example, drag and drop, okay, to move. And well, I can do this on a Mac, but you can drag and drop to move or copy files. You can delete files, you can rename files, and those are kind of important. And now we're going to start Visual Studio. And okay, I'm going to no, I don't know how to say it, but I'm going to start like a document. Okay, I'm going to start a new project. Then we go to empty project. Next, we need to put a proper name. For example, tutorial file. Okay, for week 1. Okay, then I think it's okay. Is it correct? Oh no. Okay, I'm going to make sure. Okay, we go to desktop. No desktop. To go to the drive. I think it's users. Then we go to documents, Visual Studio, and then we go to projects and select projects. Then we go to create. Okay, it's going to take a while. Okay, here we are in Visual Studio. We go to view, I think, no, project. We add a new item. We select C++ file. Then instead of CPP, which is C++, we go to just source.c. Okay, and like a proper name. Tutorial file week1.c. Then we go to add. Okay, and I'm going to put this include standard input output header, then int main, then to put int x equals 30. Okay. Yeah, we're going to put that. No, but I'm just going to put printf. Oh shit. Okay, then we go. Okay, hello, Alex. Okay, then we go to here. Then return 0. Okay, now we're going to save it. Control S. Yeah, I think that's all. And we close it. Oh wait, didn't I? How is to save it? Oh, okay. Then we open Party. Go to Matrix. Okay, I'm going to CA. Yeah. No, maybe not. I'm going to start. Oh, I don't remember Windows CP. I think. Yeah. Tricks. College.ca. Then family, and then my password. Then we save it. Oh, maybe not. I'm not going to save it. Just going to log in. Yeah. Continue. Then we start a session, open session in Party. I put my password. Ah. Okay, I think we're fine. So now what we're going to do is move the file from here to here. Okay, so to go here and I think we're on projects, tutorial. We move I think that's okay. Then we go to GCC tutorial file week1.c. Wait, whoa! Oh, no. ls change directory. Okay. Now I'm going to GCC tutorial file week1.c. Yeah, if nothing happens, it means that it runs successfully. So now I'm going to GCC tutorial file week1.c. Then I'm going to create like an executable file. We're going to call it tutorial file week 1. So now, yeah, I'm going to tutorial file week 1. Hello Alex, okay, I think it's okay. And yeah, okay, so right now I'm just going to check that everything went okay, and I'm going to open here just to check if I did all the steps. Okay, so now, okay, we did this, enter, no, check on, yeah, add a new item, yeah, we put it in C, and that's okay. We need to build a solution. Well, okay. It was not. It was okay. It's necessary because before running it, you need to. Okay, but never mind. I'll do that next time. Check the. Okay, it goes with the extension.c. And okay, when the compile was successful, run your program. Okay. No worries. Okay, I did this. Okay, not this. I didn't did this, but I knew where was my file. Okay. So now, okay, it's fine. Yeah, it's fine. And test your solution on matrix. Select a cluster, which is a host witness CP. Okay, yeah, it goes. Okay, yes, continue. Well, I opened. Well, I opened that with Putty. Yeah. Yeah. Well. Yeah. I did all of that. Okay, so yeah, it's already in my mind. Okay, so that's pretty much all. I'm going to, yeah, now I'm going to exit. Okay, and terminate close application. Yep, and that's all for today. Anyways, thanks for watching and bye byes.